All right, ladies and gentlemen, we're going to do lesson 33. It's finding probability of independent and dependent events. So it may take a little bit longer in our notes today because there's lots of problems, but it's really good information. All right, so let's first discuss independent events is the outcome of the first event does not affect the outcome of the second event. So example, what you choose for pizza toppings does not affect how many slices of pizza you eat. Well, it might if it's something you like or you don't like. Let's try that again. What color your shoes are does not affect your grade on your math test. Okay, independent events. Dependent events, the outcome of the first event does affect the second event. So you take a piece of candy out of your Halloween candy and you eat it, and then you go back in. Well, now you don't have that piece there. So that's a dependent event. All right, so a card is chosen from a deck of cards. It's put back, so replaced, and then a second card is chosen, independent or dependent. Well, this is an example of independent because you put the card back, so it's still there to choose for the second time. Now, if we didn't put the card back, then it would be dependent because now our outcomes have changed. Okay, a marble is drawn from a bag, it's kept, and then a second marble is drawn. This is a great example of a dependent event. So we took it, we no longer have it as a choice, so then it is a new amount of outcomes. Okay, a coin is flipped and a number cube is rolled. Well, whatever we flip on the coin, heads or tails, is not going to affect our outcome for the number cube being rolled, so independent. A spinner is spun, the result is recorded, and then the spinner is spun a second time, independent or dependent. Well, even though it's recorded, it's not going to change the ones we can do, so independent. All right. Then we have a coin that's flipped and a six-sided number cube that is tossed. Make a tree diagram to represent the possible outcomes. What's the probability of landing on tails and an even number? So two things here. It says we have to make a tree diagram and then it asks us this question. Okay, so tree diagram. If we flip a coin, we have the option for heads and we have the option for tails. Now, then we roll a die. So six number cube is tossed. So we could roll heads and roll a 1. We could flip heads and roll a 2. Flip heads, roll a 3. Heads and a 4. Heads and a 5. And heads and a 6. We can do the same thing with tails. Tails and a 1. Tail and a 2. Tail and a 3. Tail and a 4. Tails and a 5. And tails and a 6. Okay, what's the probability of landing on tails and an even number? Okay, so the probability of landing on tails is going to be 1 out of 2 because there's one tail out of 2 possibilities, heads and tails. Okay, now we multiply because of this and. We're going to multiply an even number. Well, how many even numbers are there? 1, 2, and 3 even numbers out of how many total possible outcomes? 6. So we multiply across and we get 3 over 12, but as always we want to reduce, so we have 1/4. Okay, so that's our probability of a tails and an even number. All right, a bag contains 4 red blocks and 3 blue blocks. Find the probability of drawing a red block, you keep it, and then you draw another block. Okay, so probability of drawing a red block. There are 4 red blocks. Out of how many total blocks is 7? Okay, and then we have the word and, so we're going to multiply. And then another red block. Okay, but we kept it, so now we only have 3 red blocks to choose from. Out of how many total? Well, we have 6 total. Okay, so we're going to go ahead and multiply our top numbers, and we get 12. And we're going to multiply our bottom numbers, and we get 42. Okay, but we always want to reduce, and so that reduces down to 2 over 7. So we can divide both by 6. Okay, G, find the probability of drawing a blue block, keeping it, and then drawing a red block. All right, so we look at with blue blocks. We have 3 blue blocks out of 7 total. Okay, this time we're keeping it just like the last time, so we have less in our total. So we have 6 in our total now. Okay, and then drawing a red block. Well, red blocks weren't affected by that blue block we took. So we have 4. So we are going to multiply straight across again because of the word and. And we get 12 over 42, which we saw in the last example, we know is going to reduce to 2/7. So drawing a blue block, keeping it, and then drawing a red block is going to have a probability of 2/7. Okay, so we've been talking about probability. Probability is the number of successes out of the number of total outcomes. Now we're going to talk about odds, and odds is a little bit different, and we're going to talk about favorable outcomes versus unfavorable outcomes. Okay, so if we look at the spinner on page 208, we see some black and yellow and gray triangles in that spinner. Okay, what is the odd of spinning black? Okay, so remember, if we look back here, favorable versus unfavorable. So how many are black? Those are favorable. Well, there are 2 black ones. Then we see how many are unfavorable. We'll count how many that are not black. So there's 3 white and 3 gray. So then that's 6. And again, we should reduce to 1 versus 3. So the odds of spinning black is 1 out of 3. Okay, what's the odds of spinning gray? So we want favorable, and there are 3 gray, versus unfavorable. So there are 3 white and 2 red, so that's going to, oh, wait, this says against. So against means how many are not gray the first time. That's 5, 3 white and 2 black, versus how many are gray. So this one we write backwards because it's against. All right. The last topic says campers select 1 inside activity and 1 outside activity daily. There are 5 inside activities and 8 outside activities. What's the probability of choosing pottery and horseback riding on the first day? Okay, so pottery is one of your inside activities, so that's 1 out of 5. We have our and, so we're going to multiply. Horseback riding on the first day, so that's 1 out of the 8. So we're going to multiply across and we get 1 out of 40. So it's a 1 out of 40 chance that we're going to pick pottery the first day and horseback the first day. K says inside activities can be repeated, but outside activities cannot. So what's the probability of choosing pottery and swimming on the second day? Okay, so pottery is still 1 out of 5. Okay, swimming is, there's still just 1 choice of swimming, but now we don't have 8 choices, we only have 7 choices. Okay, so then we have 1 out of 35. So change that second number a little bit because we can't repeat. All right, there you go.